most of the data you will encounter won't be tidy. So as a data analyst, it will be your job to figure out how to make the data into a tidy format. So pivot longer and pivot wider are the two most important tidying tools from the tidyR package. In this video, we will look at pivot longer function. Now what the pivot longer function does is it lengthens the data. That means it increases the number of rows and decreases the number of columns of the transformed data set. So let's first recall the tidy data principle. Before we use pivot longer function, let's first recall the tidy data principle. The tidy data principle says that each variable has its own column, each observation has its own row, and each value has its own cell. And if the data set doesn't fulfill one or more of these characteristics, then the data set is called as a non-tidy data. In my earlier video, I explained the tidy data principle in detail. So if you're interested in finding out more about the tidy data, you'll find the link in the description of this video. I'm going to load the tidyverse package, and the data that we are going to use in this video is on the number of bald eagle nesting sites across multiple regions and years. Okay, and what I've done here is I've created a data frame called eagle data and copied the eagle nest data into it. You will also find the CSV file on my Github repository. If you want, you can uncomment this code so that you can directly load the data from the Github repository into your R session. Now let's view the data. Let's view the data. So this is how the data looks like. Now, of course, as you observe that this is not a tidy data set. Now let me quickly explain to you why it is not a tidy data. So this is the data set that we saw earlier. This is the untidy data. Now you can see that the column names, these column names 2007, 2009, they are not actually the names of the variable, but they are the values of the variable. So for example, I can create a column called year, and I can convert these column names into the values. Okay, so that is first observation. And the second observation is that these values that you see, these values are not the values for the year 2007, 2009, but they are in fact the values of number of nests found. Number of nests found at bald eagle nesting sites. So the values of the nests are stored as the values of 2007 and 2009. So you have two anomalies here. You have column names being represented as values, and the values are actually meant as number of nests, but wrongly been labeled as the values of the year 2007 and 2009. So in order to convert this data set into a tidy data, we need to pivot 2007 and 2009 into the year column and values of 2007 and 2009 into the number of nests column. So our tidy data set that you see on the right will have three variables. You have region variable, which we kept as it is. Then we have the year variable. This is the new column that we created, which will have the year the nests were found, and the number of nests column. This also is the new column that we created, which will have the number of nests found, all these values. So let's get back to the R code and see how we can able to use the pivot longer function to make this data set tidy. So I'm going to pipe in the data set into pivot longer function. So eagle underscore data. But before that, I would like to use the select function from the dplyr package because I want to drop the first column here. since that column only mentions the row numbers and doesn't have any significance in our data set. So let's drop the first column from the data set. Select with exclamatory mark and the name of the first column, and then let's use the pivot longer function. So pivot longer. So here you will have to mention the names of the columns to pivot. So columns equal to C 2007 comma 2009. Now in our case those columns are 2007 2009. Now please note that I have put in these column names into backticks because they start with numbers. Then comes the name of the column that will store the old column names. So in this case we have to create a column name called year. So names2 equal to year. So it will store the old column names. The values of the year column shall be 2007 and 2009. So please also make sure that you double quote the new column name. The new column name that we have created, the year column, since it does not exist in our original data frame. So just as we have created the year column with the names2 argument, we'll have to create another column called num nests, which will have the values of the number of nests. So values2 equal to num nests. You'll also have to make sure that it also double quote this name, because this is also the second column that we are creating, second new column that we are creating. So this pivot longer function, we have used three arguments. The first argument is columns argument, which will have the names of the columns from the old data frame. Then the second argument is names2, which we created a new column called year, and that column will have the values as the names of the old data frame. And then the third argument is values2. We created a new column called num nests, which have the values of the number of nests from the old data frame. Okay, so we are ready to execute. Now let's execute this function. So you can see that the transform data frame is into a tidy format. So it has many rows and few columns compared to the non-tidy data. Let's take another eagle related example. So eagle pairs, this data set contains the data on the number of observed bald eagle breeding pairs across years and states. So let me load the data. Again, you can see that this data is not in a tidy format, because the names of the column, all the names of these year columns are not actually the names, but they are the values of the variable year. So let's convert this data into a tidy format. So pivot longer function, again I will start with the data frame. I will use the select function to drop the first column from the data frame. Pivot longer. Now here I am going to use the helper function starts with. So columns, so I will use exclamatory marks, columns equal to exclamatory mark starts with state, then names2 year and values to nums pairs. So let's view this data. You can see the data is now converted into a tidy format. Now let me come back to the tidy version of the eagle pairs data. So this is the tidy version of that data. Now you will observe that there are many missing values. There are many missing values in it. So all the observations with the missing values can be dropped by setting values drop any argument to true. So in the pivot longer function, let me copy this, and the fourth argument that I will be using is values drop any argument, and I'm going to set the value to true. Now let us execute this, and you will find that the number of rows are reduced because all the NA observations are dropped from the data frame. Now another thing to note about the pivot longer function is that the names to column by default, pivot longer function creates the names to column as a character variable. So let me go back to the tidy data, and as you can see, the year column, the data type of the year column is character. Now it is probably more useful to store this year as an integer. So we can use the names transform argument from the pivot longer function to change the data type of names to column. So let me copy this code and let me write the fifth argument, names transform equal to list year equal to as dot integer. Now please note that the names transform argument takes a named list of column name, and as dot method. Okay, so it's a list that you have to supply to the argument names transform. Now so far there are four important pivot longer function arguments that we covered here: names to, values drop NA, and names transform. These four arguments will cover most of the use cases. However, there are plenty of other function arguments available for the pivot longer function, and those, if you use, will give you more control on the usage of pivot longer function. So you can have a look at tidyR page. I've given the link in the summary section, so you can have a look and explore more arguments of the pivot longer function. So let's quickly summarize. Pivot longer lengthens the data. It increases the number of rows and decreases the number of columns. It moves the data from column names to cell values. Pivot longer function takes three important arguments. We saw them: the columns to pivot, the names to store the column names, and values to store the column values. Pivot longer has the other useful arguments, and you can refer to the tidyR package page to explore some more arguments that are part of pivot longer function. Thank you so much for watching this video. If you like this video, you may subscribe to this channel, hit the like button, and also I will also appreciate if you can leave your suggestions in the comment section so that I can improve upon the content and reach to more and more our learners. Thanks for watching. Take care and goodbye.